Dear students, in previous class we discussed about functions and limits, and now we will discuss about same chapter, that is functions and limits, and we will some more topics, some more related problems on limits and properties and formulas or rules we will learn today or in this class. Objectives of the this class: on completion of this period you would be able to know properties of limits, standard form of limits, methods of limits. Chapter name is, or topic name is, limits. Properties of limits. Number 1, limit extends to a k into f of x equals to k into limit extends to a f of x. Number 2, limit extends to a f of x plus or minus g of x equals to limit extends to a f of x plus or minus limit extends to a g of x. In first property, the k is a constant, so we put it outside. In the second property, there are two functions and they are having in between plus or minus. So for each function we can split the limit. So this is a summation of two functions. So for every function and using or putting limits, and we will separate by putting plus or minus to each function. Number 3, limit extends to a f of x into g of x equals to limit extends to a f of x into limit extends to a g of x. Not only plus or minus, if the product is there of the two functions, we can put limit for each function and as a product. Number 4, limit extends to a f of x by g of x, that equals to limit extends to a f of x by limit extends to a g of x. So in the fraction we have numerator and denominator, that means two functions, and for each function we can give the limit, or we can put or write the limit. So in the numerator we applied limit, and the same taken in the denominator also. So additions and product and division. So in the both the cases every function contains limit. We can give each function a limit. Next, fifth property, limit extends to a f of x whole power n. So we can use the limit in a bracket and keep the bracket outside of limit, and we can give whole power of n, that is the limit extends to a f of x whole power n. So in the right side the whole term is kept in a bracket except for power is outside. In the left side only f of x whole power n. So that we can take the limit inside the bracket and we put the power whole. So or if it is totally covered, we can take outside also the limit from the function. So this is the property. Next, sixth, limit extends to a sine f of x. We can write it sine of limit extends to a f of x. So we can take sine outside and bring the limit inside. Next, number 7, seventh property, limit extends to a log f of x equals to log of limit extends to a f of x. So we can take log outside and we can bring the limit inside. 8, limit extends to a e power f of x equals to e power limit extends to a f of x. LT or LIM both are same. So here the limit is given to the power, which is f of x on the power of e. So we take in the limit in the power and we kept for f of x. So we can write we can say e power limit extends to a f of x. Here LT or LIM indicates same. Standard limits. Up to now we observed the properties, and now we see or we learn or we say it is a formulas. So let us see. Prove that limit extends to a x power n minus a power n by x minus a equals to n into a power n minus 1, where n is any rational number. Proof. Let f of x equals to x power n minus a power n by x minus a. F of a equals to, in place of x we are taken a, so put a wherever is x in the right side also. So a power n minus a power n by a minus a, that equals to 0 by 0. Indeterminate. So we cannot define this. Let x equals to a plus h. X tends to a, that implies h tends to 0. F of x equals to f of a plus h. So in place of x we are taking a plus h. So substitute in the function, in place of x put a plus h, then that equals to a plus h whole power n minus a power n by a plus h minus a, and that equals to a plus h whole power n minus a power n by h. 1 by h into an plus nc1 into a power n minus 1 into h power 1 plus nc2 into a power n minus 2 into h power 2. Like binomial theorem, we are expanded that, and minus a power n that equals to plus a power n minus a power n get cancelled, and remaining nc1 into a power n minus 1, h also cancelled, plus nc2 into a power n minus 2 into h, plus up to so on h power n minus 1. Limit x tends to a, f of x equals to limit h tends to 0, f of a plus h, that equals to limit h tends to 0, nc1 into a power n minus 1 plus nc2 into a power n minus 2h, plus up to so on, plus h power n minus 1, that equals to nc1 into a power n minus 1, that equals to n into a power n minus 1, since nc1 equals to n. So finally we got the proof, that is n into a power n minus 1. Second, a trigonometric limit. Prove that limit theta tends to 0, sine theta by theta equals to 1, where theta is expressed in radians, that is 0 is less than theta is less than pi by 2. See the diagram or figure here. OA is the radius of the circle, and AT is the tangent line, and AN is a perpendicular line or normal line. OAB is a triangle, and here let AB be an arc of a circle with the center O. Let the radius of the circle be R. Let the arc AB makes an angle theta radians less than pi by 2 at the center, that is angle AOB equals to theta. Angle AOB equals to theta. AB is the arc, AO is the radius, and angle AOB is a theta. Let AT be the tangent line at A cutting OB in T. Cutting OB in T. Cutting OB in T. Okay. Join A and B. Draw AN perpendicular to OB. From triangle OAT, OT equals to OA by cos theta. OA equals to R by cos theta. Then area of triangle OAB equals to half into OB into AN. That equals to half into R square into sin theta. Area of triangle OAT equals to half into OT into AN. That equals to half into R square into sin theta by cos theta. That equals to half into R square into tan theta. Area of sector OAB equals to half R square theta. From the figure we find area of triangle OAB is less than area of sector OAB is less than area of triangle OAT. Half R square sin theta is less than half R square theta is less than half R square tan theta. Divide throughout by half R square sin theta. We get 1 is less than theta by sin theta is less than tan theta by sin theta. That is theta by sin theta is less than 1 by cos theta. Because tan theta means sin theta by cos theta. So sin theta get cancelled. So we have 1 by cos theta. Inverting the above inequality, we have 1 is greater than by sin theta by theta is less than cos theta. That is, there since a is less than b, that implies 1 by a is greater than 1 by b. So in order to this, we can say it is a greater than. So here the symbol is wrongly spelled or wrongly printed. So that is 1 after sin theta by theta, symbol is not less than, it is a greater than. Now take limit theta tends to 0, sin theta by theta is greater than limit theta tends to 0, cos theta. That implies 1 is greater than limit sin theta by theta is greater than 1. Value of limit theta tends to 0, sin theta by theta lies between 1 and 1. Therefore, limit theta tends to 0, sin theta by theta equals to 1. 1 and 1 means there is only 1. So, this is the formula which is indicated in a background background pink color shaded. Background is in pink color. So this is what we proved, and the proof is not required generally and not comes in the exam, but to know you how to get the proofs or how the formulas framed, that is here given for you to understand clearly and to know clearly how the formulas are made or had particular values. Other standard forms. Say every formula we need not to prove. For one to for our understand they are given. If you want more or each, you can see the textbook. In the textbook there are given the proofs, and see here. First one, limit extends to a x power n minus a power n by x minus a equals to n into a power n minus 1. This formula is we are proved just now. Limit extends to a x power m minus a power m by x minus n minus a power n. Then we can write m by n a power m by n into a power m minus n. Third one, limit extends to 0, sin x by x equals to 1. X is in radians. Fourth one, limit extends to 0, Sin mx by x equals to m. X is in radians. Limit x tends to a, tan x by x equals to 1, x in radians. Limit x tends to a, tan mx by x equals to m, x in radians. Limit x tends to 0, cos x equals to 1, x in radians. Limit x tends to 0, cos x equals to 1, x in radians. Eighth formula. Limit x tends to 0, a power x minus 1 by x equals to log a to the base e. Ninth one. Limit x tends to 0, e power x minus 1 by x equals to log e to the base e equals to 1. Limit x tends to 0, 1 plus 1 by x whole power x equals to e. Limit x tends to 0, 1 plus x whole power 1 by x equals to e. Methods of limits. When limit x tends to 0, f of x is given, expand the terms in f of x, cancel if necessary, and directly substitute x equals to 0. Second point 1. Limit x tends to a, f of x equals to f of a not equal to 0. Substitute x equals to a in f of x. Second, factorization for rational function. Rationalization for irrational functions. So these are, we can easily know when the questions are given. So this is a theory how to do if the question is given in a different way. Some questions we do directly substitute the limit. Some we have to rationalize, some we have to factorization, some we have to rationalization. For indeterminate form like 0 by 0, 0, infinitive, 0 power infinitive, 0 power infinitive, 1 power infinitive, infinitive by infinitive. Put x equals to a plus h. As x tends to a, h tends to 0. That is, limit x tends to a, f of x equals to limit h tends to 0, f of a plus h. Now use first method to calculate the value of the limit. Third one, To evaluate limit extends to infinitive f of x, substitute x equals to 1 by y, then x tends to infinitive, that implies y tends to 0. That is, limit x tends to infinitive, f of x equals to limit y tends to 0, f of 1 by y. Limit x tends to infinitive, f of x equals to limit y tends to 0, f of 1 by y. Now we have to use first method to calculate the value of the above limit. So we are converting from infinitive to 0, and we can easily find the limit. We know the limit value. Now quiz. First one, limit x tends to a x power n minus a power n by x minus a equals to, 4 options are given. Let us see. A power m minus n. Second one, a power n minus 1. Third one, m into a power n minus 1. Fourth one, n into a power n minus 1. So answer is fourth. Next, limit x tends to a sin mx by sin nx equals to, first one m by n, second one minus m by n, third one n by m, fourth one minus n by m. So answer is m by n. Here for answers, the correct answer is marked with a star. Limit theta tends to 0, cos theta equals to, first one minus 1, second option 1, third option 0, fourth option 2. So answer is 1. That means correct answer is option 2. So answer 1, but the 1 is given at second option. So second option is correct. Summary. In this session, you have learned properties of limits, standard forms of limits, methods to find limit value of the function, so mainly in this class we learned about limits and properties of limits, standard forms of limits, methods of limits. There are so simple properties, as we know, or in earlier school age at 10th or in the ninth standard, we know some limit problems or limit properties. We can now also we can easily remember these properties. So here 8 properties are given. These properties can be used for finding the value of the limit of the given function. So some formulas also here given with proofs. These formulas are also used to find the limits for the functions, different functions. By using formulas, we can save the time and a lot of labor work or the paperwork we can save. So many steps will be we are need not to write if we use the formulas. So memorize the formulas, and better if you write each formula 10 times in the running notes or rough notes or on the page. You can write 1 or 2 times in our mass fair notes before going to do the problems. Write its properties and its formulas, or we say standard limits. And one proof is we did, that is limit extends to a x power n minus a power n by x minus a equals to n into a power n minus 1. And one more we proved, that is trigonometric function. Limit theta tends to 0, sine theta by theta equals to 1. So these two are important, and some other standard forms also given. That is, now we read once again, and in the running notes or on paper, to memorize we have to write each formula 10 times or 20 times. These standard forms very useful in the exercise problems. So to memorize these formulas, you should write number of times. So let us recall or read once again. First one is limit extends to a x power n minus a power n by x minus a equals to n into a power n minus 1. Limit x tends to a, x power m minus a power m by x power n minus a power n equals to m by n into a power m minus n. Third one, limit x tends to 0. Sin x by x equals to 1. Fourth one, limit x tends to 0. Sin mx by x equals to m. Fifth one, limit x tends to a, tan x by x equals to 1. Limit x tends to a, tan mx by x equals to m. Limit x tends to 0, cos x equals to 1. Limit x tends to 0, a power x minus 1 by x equals to log a to the base e. Ninth one, limit x tends to 0, e power x minus 1 by x equals to log e to the base e equals to 1. Limit x tends to 0, 1 plus 1 by x whole power x equals to e. Limit x tends to 0, 1 plus x whole power 1 by x equals to e. Methods of limits. When limit x tends to 0, f of x is given. Expand the terms in f of x. Cancel if necessary and directly substitute x equals to 0. Second point. In the second point, we have subpoints, that is first one, limit x tends to a, f of x equals to f of a not equals to 0. Substitute x equals to a in f of x. Second point, factorization for rational function. Third one, rationalization for irrational functions. Fourth one, for indeterminate form like 0 by 0, 0 infinitive, 0 power infinitive, 1 power infinitive, or infinitive by infinitive. Put x equals to a plus h. As x tends to a, that implies h tends to 0. That is, limit extends to a, f of x equals to limit h tends to 0, f of a plus h. Now use first method to calculate the value of the limit. To evaluate limit x tends to infinity f of x, substitute x equals to 1 by y. As x tends to infinity, that implies y tends to 0. That is, limit x tends to infinity, f of x equals to limit y tends to 0, f of 1 by y. Now we have to use first method to calculate the value of the above limit. So whenever we are going to find the values of the limits for given functions, we have to follow these methods. And in next class we will discuss how to do the problems, and meanwhile you can see the example problems which are given in our textbook, and after understanding example problems you can start doing exercise problems. And if you have any doubts, you can call me or message me on WhatsApp, and I will clear your doubts, and we will discuss some more in next class. Thank you.